Howdy hackers, and welcome to another episode of FairLight TV, your favorite show on YouTube. This time we will conclude the deep dive into the machine code monitor of Vice, the C64 emulator. It's also emulating other machines, but for the purpose of this, we only care about the C64 emulation. What is going to be handled in this last episode? Well, we've already given that away in the introductions for episode 1 and episode 2. It will be the breakpoint system, and also to some extent the combination with playback files and log files, which makes it amazing, totally amazing in terms of what you can do, the superpowers that you can have by joining these three. It's like 1 + 1 + 1 = 10 or something. But I'm not going to hold this. I'm only going to say welcome, and let's go over to deep dive into the Vice monitor. So what you saw here was me doing a break on 1000 and another break on 1200, and as you see here, the first one was resulting in break 1 on address, and it also states that it's on execution because it's a break. And then I did the 1200, and you see the index here. So there is a break 1 and a break 2, and these indexes are the ones that you henceforward are using to reference. And if you combine this with the PB files, it could be a bit complicated, because if you're issuing a break inside a PB file, that break is just added to the list, and it will have an index which is the last one in the list. And if you're using a subsequent command in your playback file, using an index to that particular breakpoint, you're not really sure if that index is correct for what you were using it for, because if there was a previous breakpoint before you issued the playback, then the index of the breakpoint that you were adding using the PB will be off. So if you just issue it like this, you would see a list of the breakpoints here. But what you will let me add watch 2000, yeah, well, whatever that was, and then break. You can do watch as well, and you see it's doing the same thing. Delete 2. So here I am deleting the second breakpoint, and then if I issue break again, you would see that now the breakpoint 2 is gone. And then I do break 4000 here, and I do break again, and then you see here it added the last breakpoint on the, not the first available, because that would be 2, but it's adding it to the last position of the list. The good thing here is if you just issue delete or del, and then do break, and then do break 1000 again, it will reset the count. So if you have an older version of Vice, it would actually add that new breakpoint as 5. But now what Vice is doing, when you clear the last breakpoint, it resets the count, and any subsequent breakpoints will be added from index 1. Okay, so that was that. Yes. Okay, and so a breakpoint stops execution. A trace point doesn't stop execution. It reverts back to the console and prints something. Let's see where we are here. Yeah. So I was thinking if I could quickly do something that would generate a trace point. But I think you're sort of catching the drift here, that a trace point is a handy way of not kind of interrupting the running machine. It's just printing to the console. So when you launch the machine code monitor again, you can look at what's in the console and see what the trace points that execution has hit since well, before you're entering the monitor again. So that's what a trace point is doing. So think of tracepoint more like a logging function that logs to the console here. But of course, if you add the log and then add trace points and then you run, you would actually have that log to a file. And if you're like I do a lot of times, I set a trace point to the loader. And then I just play the game for a while, and then I can look back to the log file, and I can see the parameters I used for, or that were used for calling the loader, or when calling the loader. And I will show you one other thing here with the break command. So break 1000, and now that one has index 1. You can do command. A command called command is really confusing because you don't know if you're talking about a command or the command, but there is a command called command, and then command 1, and then you do M4041. That's typically. So what happens now is that whenever breakpoint number 1 is triggered, this command is issued. So the command inside the string here is issued. And what you can also do is you can stack, so you can do M5051 and then yeah, whatever, disassemble 1000 to 1010. Let's see where I am. This assembly here, so it is here. So if I set a breakpoint to somewhere, it's just going to do to execute will be OAEC break EC. Okay, so that's up on execution, and then I can go up, and this was adding as, and we do this. Okay, so what if I do exit now? It would run a few instructions, and then it would enter because it's tripping on that breakpoint, and it would issue the M, and the D here. What did it do? It did these two M's, and it did a disassembly of that. So that one worked. So that's how command works. Really, really strange, but you can do it. The only annoying part here is that let's do break here, and you also see that the breakpoints, they have associated commands here. The annoying part here is that this needs to be a string, and you can actually call a playback file. So if you trip on breakpoint 2 here, you want to execute a PB file. So I'll show you how that is done. Yeah, so command 2 like that, and then you do PB, and then you do that, and then you do PB file, and then you do that, and then you do that. So this is the way to do a string inside a string. So whenever you are now tripping on that secondary breakpoint, you are executing a PB file with the name PB file. Yeah, that's sort of a pro level thing. Let's see what else I have. Yeah, I can do record that one as a command as well. Let's see what else I have in my script that I wanted to tell you about. Yes, this is all taken care of. Yeah, so if you have an early version of ICE before 3.4, I think, if you set a a watch point for load to 1000, you could sometimes have that trigger, and if you look at the instruction that triggered, it wouldn't actually access that that area that you were having deciding that you wanted to take a look at. It's probably like more like that. You're looking at an area where if somebody has been tampering with an area. And the reason for this is quite deep into the actual CPU architecture of the 6502 or the 6510 in this case. There is some sort of a dummy read. So it's actually reading, but the address, and I'm not going to say it's random because it's not, but it's reading an address where it's not going to fetch the content of that actual address. So it looks like it's reading, but it's really not. It's the subsequent cycle of the read instruction is actually fetching the data from the correct place. If you take a look at the device bug list, there is a bug called 1134, which I issued because I had no idea that this was how it worked. And there is a reference to the 6502 manual that tells this tell you about this dummy read. So what they have done instead, and I complained because for me this was totally useless. The watch load became very confusing if it was also triggering on those dummy reads, and I wasn't interested in the dummy reads, and for me absolutely nobody would be interested in those dummy reads unless they had any particular purpose for some sort of VIC trick or whatever. So what they kindly implemented was the dummy command. This is my understanding of the dummy command. So dummy is enabling or disabling that triggering of breakpoints or checkpoints for these dummy reads. If you want to read up more on this, I suggest you take a look at the device homepage in the on the bug tracker on issue 1134. 1134. That. Because that's where it's described. And if you really want that dummy to trick you, then just do dummy on. Default is luckily off. Okay, yes. And I did show you that you can enable, disable, or delete them. So break lists them. You can enable, or they are all enabled. So you disable number 2, and then you do break. Now you see here, it's a bit hard to read following adding the command, but here you see that this one, break 2, is now disabled. And then you can delete all of them like this, or you can delete one specific one like that. And as you saw before, break, trace, and watch, they all give you the same list. So it's and they are listed here as break and watch. I should possibly also add a trace 1000, and now I have a trace point on execution on 1000. So you see here that on load, store, and this one is doing all. It's load, store, and exec. So whenever the address 1000 is involved in anything, it's now printed in the console. And of course trace exec. So now you see that this is a specific one that only triggers for if you execute address 1000. Not that this is relevant, but of course I want to ensure that I don't have like 2 breakpoints for the same thing. I would imagine that it checks them from start to finish. So if you have breakpoints on the same address, multiple breakpoints on the same address, it will probably take the first one and reference that. And that wouldn't make any sort of difference unless you have commands that would be different for the two. Then it would take the command that is associated with the earliest one. Yeah, and I did show you now that yeah, so my pro level here was trace break. Okay, so let's say I have a trace to 1000, and then I do this command 46 M40 to 41, and then yeah, M50 to 51 like I did before, and then you can log name my log.txt, and then you do log on. So what happens now when you run this, every time you have a trace, it would add to that log file, which is super convenient, again, for logging what happens without having to get the monitor interface up every time and pressing X to exit it. So this is what you do. So these are all the commands. I think I skipped one or two. There is key buffer, there is screenshot, and there is print. So key buffer is adding characters to the key buffer. Yeah, nice. Print just prints. Yeah, nice. Screenshot is saving the current screen as a screenshot. Yeah, nice. I always do that using the GUI anyway, but these are commands that are there as well. And tape control, I already talked about that one. So yeah, these are the commands of Vice Monitor, and I encourage you to explore the huge potential or the huge power you can unleash by combining PB files with the command with the breakpoints. What you can do is absolutely amazing. So that's everything we had for this time. So very, very thankful to you for spending the time to watch FairLight TV. We would like to welcome you next week to FairLight TV. Bye-bye. That was all for this little mini-series. So you've now seen 3 segments that together build up a rather thorough exploration of the functionalities that you have access to using the Vice Monitor. Yeah, there was one command. Let's see where I have my note. There was one command. Oh yeah, it would be the SC for screen. My little scribbly notes of stuff I realized that I didn't manage to go through. SC, it's used in the first segment, I think, but it's not really explained. So it shows you sort of a dump of the screen, so don't miss that one. I'm sorry for not having that like in the proper place in segment 1. If you've gone through all these 3 episodes, you possess the superpower of knowing what to do with Vice, the emulator, and the monitor inside of it. I would like to thank you for staying put and watching all 3 episodes. If you missed one of them, they are in the log back, so just open the FairLight TV YouTube channel and you will have access to all the previous episodes as well. So don't miss any one of them. We are so thankful that you are watching. We are also going to welcome you next week. Hopefully next Friday you will be able to see the next episode of FairLight TV. And what we will cover? Well, to be honest, I don't know yet. But I hope I know by the end of this week so that you can also learn something new on the C64 low-level hacking. Or possibly something on Amiga low-level hacking. We never know. See you next week.